Today I want to talk about algebraic inequalities, and we'll start with an example. What set of values satisfy that inequality? Well, how are we going to solve that? We could start by multiplying both sides by x minus 2. Oh dear, what happened there? We were multiplying both sides by x minus 2, but we don't know whether x minus 2 is positive or negative. And if we multiply both sides by a negative number, we should change the inequality. So we have a problem. It's quite easily solved with a nice little trick. If we remember that when we square any number, it's always non-negative. So in this case, x cannot be 2 because it's on the denominator. So x minus 2 all squared actually has to be greater than 0. It can't be 0. So x minus 2 all squared is always positive. And when we multiply both sides by x minus 2, we have a problem. If we multiply both sides by x minus 2 squared, the problem disappears. Because we've multiplied both sides by a positive number, we don't have to change the inequality. A little bit of algebra now, and we will get that 2x plus 3 x minus 2 squared less than x squared x minus 2. What are we going to do next? Some people might multiply out. They would not be doing something sensible. We will always, because we are multiplying by x minus 2 squared, there will always be, as it were, a surplus, an extra factor of x minus 2. So if we first of all subtract x squared x minus 2 from each side, then having done that, we can factorize. And you will always be able to do some factorizing when you're doing this. If we take x minus 2 out, we're left with 2x plus 3, x minus 2. If we take x minus 2 out, we're left with x squared less than 0. X minus 2. Inside the big bracket, we have 2x squared plus 3x minus 4x is minus x, minus 6 minus x squared, less than 0, nearly there, x minus 2, 2x squared minus x squared, minus x minus 6, less than 0, and therefore we have x minus 2. Factorizing this, we get x plus 2, x minus 3, less than 0. Right, now how can we discover when that is less than 0? What would you do now? Well, if we look at the function on the left-hand side of the inequality, it's of degree 3. The coefficient of x cubed is positive, so that means that it's got to look something like that as a function. and its 0 values where it meets the x-axis are 2, -2, and 3. So all I've got to do is get that curve onto there. A bit wobbly, but not too bad. And we now want to write down when is this function less than 0? When is the graph below the x-axis? Well, this is going to be when x is less than -2, or, and I do like to see some connection between everything, when x is between 2 and 3. So there is the solution to that. The graph is below the axis when x is less than -2 or between 2 and 3. There are various other ways of doing this, but I think that what we have here is quite nice, quite simple, and it works easily. The trick at the start is to multiply by a perfect square. That's positive, so it doesn't upset the inequality. The next thing to remember is to factorize rather than multiply out. And at the end, it's going to be very quick and easy to sketch a graph. Let's look at another example, just a little bit more complicated, but much the same trick. We want to get rid of the denominators, seems a sensible thing to do. Multiplying by x plus 1 is not a good idea. We don't know if it's positive or negative. So we're going to multiply by x plus 1 squared. And at the same time, we're going to multiply by x plus 3 squared. So in this case, we are multiplying by x plus 1 squared, x plus 3 squared. If we do that, we will get x, multiplying by x plus 1 squared, I'm left with x plus 1 on the top. Multiplying by x plus 3 squared, I get that. Less than or equal to 2, multiplying by x plus 1 squared. Multiplying by x plus 3 squared, one of them cancels. Only a fool would multiply that out. So we need to subtract everything from the right-hand side. Oh, it's all moving around. Less than or equal to 0. Factorize. I've got an x plus 1 and an x plus 3. Not surprising. Those were the surplus or the extra factors. I'm then left with, if I take x plus 1, x plus 3 out, I'm left with x times x plus 3 minus 2. Take an x plus 1, I'm left with 1. Take the x plus 3 and it goes. A little bit of simple tidying up now. And we are left with x squared plus 3x minus 2x is plus x minus 2. And that is x plus 1, x plus 3. If I factorize that, I'm going to get x plus 1. No, I'm not. I'm going to get x minus 1, x plus 2, less than or equal to 0. So now we have on the left-hand side, if we look at the function on the left-hand side, it's a 4th degree function. The coefficient of x to the 4 is plus 1. So this is going to be a graph which is that way up. So we now need to sketch that and just have a look and see what's going on. And that's a good enough sketch for us to see what's happening. Less than or equal to 0. That means below the axis, that's minus 3. less than or equal to x less than or equal to -2, or -1 less than or equal to x less than or equal to 1. Oh dear, not again. What's happened this time? Can't see any mistakes, can you? Everything looks all right down there. It's power 4, it's the right way up, it's below the axis. Oh. Because x plus 1 was on the denominator, x cannot be -1, and x cannot be -3. So down here, we can't have less than or equal to in two of those places. X cannot be -3, and x cannot be -1. So now we're okay. Now we have the solution of the problem, and we haven't got any inconsistencies. So that is the second point. One is to multiply by the squares. The second one is that if you have an equals there, some of your answers that you would like to write down, you cannot do.